Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. Thank you, Jason, for that amazing introduction, or Dr. A, should I say. Like he said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons, and I just love what I do. I love working with you guys. I love going over math problems and kind of giving some perspective on some problems that are just really difficult. I know these exams are not easy, and so that's why we're here every single Wednesday, is to give you that little bit of like extra motivation, extra push that you need. But if this is just not enough, we do offer boot camps. We offer one-on-one tutoring. So if you check out our website, which will be shown at the end, it's also thelearningliaisons.com. If you check out our website, you will be able to find even more things that we offer, including our boot camps and one-on-one tutoring. Myself and Priya both do math tutoring. Her schedule is a lot more open than mine is, just because of my availability with my other job. But that said, we do offer other things available. So that said, if you're new, I am from Central Florida. I am currently an assistant principal, but I have been a math coach. I've been a teacher. I tutor elementary through high school math. So I feel like I've done a lot of different things. So I am here to help you. So that said, I always like to get to know who's in the room. It helps me guide our conversation for the day. So in the comment box, if you could let me know where you're from, what test are you prepping for? And this is a funny one, and I'll explain why in a minute. Have you fallen onto the Stanley train? I feel like I've seen so many people with their Stanley Cups, and I just haven't bit the bullet and purchased a Stanley Cup. I'm just not that kind of person to like fall into these trends, but I decided I just had to have a Stanley Cup one day and just purchased it last week, and I am obsessed. My baby is obsessed. I'm obsessed. I don't know what it is about that cup, but I drink so much more water when I have my Stanley Cup than when I don't. So Where are you from? What test are you prepping for? And do you have a Stanley Cup or not? Hey, Joseph, good to see you. Prepping for that 5165. Hey, Milagros, how do you become a math tutor? You really just get your name out there. I used Facebook to kind of let people know that I was tutoring. People are always looking for math tutors. And in the schools that I was at, I just let people know that I was a math tutor. And then my mom is also a high school math teacher as well. And so when her students were looking for math tutors, she'd throw my name out there. So it's really a word of mouth kind of thing. But you can do it if that's what you want to do. Hey, Ricardo, good to see you. You're from South Florida. Like what part of South Florida? Like the Miami, South Florida, or like the West Coast, South Florida? And prepping for the middle school math exam. Awesome. No Stanley Cup. No one in here yet has a Stanley Cup. I'm applying for a job to be a tutor. Fantastic. That's awesome. All right. So before I get started, use the comments to your advantage. I am live right now. I mean, if you're watching it after the fact, I'm obviously not live. But if you're watching it right now, Wednesday, 6 p.m., I am live. Hey, Loie, good to see you. So ask whatever questions you have in the comment box. If you don't understand something, ask. And if there's something that you specifically want to see me go over in the upcoming weeks, let me know in the comment box. A lot of the problems that I'm going to go over tonight were specific requests. Someone sent me an email and said, I want to see dividing fractions. I want to see oh, I might need to go get my Stanley Cup because I have a scratchy throat. I want to see volume problems. I want to see trig functions. So if there's something that you want to see, let me know in the comments or shoot me an email. Hey, Hope, good to see you. Nobody in here is on the Stanley Cup train. That's okay. We don't all have to be Stanley Cup fans. And to be quite frank, I love it right now. And probably in 2 weeks, I'm not going to even remember I have it. So that's just how it goes, isn't it? All right, so let's go ahead and get started with problem number 1. A landowner is building a fence on her square property behind her house. The area of the property is 6,724 feet squared. If her house is 36 feet long, how much fencing does the landowner need? This is a really interesting question because it says that she has a square property. So I'm immediately thinking, and I'm going to use green just because green is the color of grass. I'm immediately thinking that here's her property, right? Here's her square property. And the area of that property is 6,724 feet squared. What does that tell me? What does that tell me? Well, if I work backwards from area, because they've asked us, let's go back. They've asked us how much fencing does the landowner need? Well, if we're looking for fencing, I'm immediately thinking that I'm looking for perimeter. Because fencing is the distance around. And area is the amount that's in. So if fencing is the distance around, that's your perimeter. How much grass do I need to fill in the entire shape would be our area, but they gave us the area. So let's remember what our area and perimeter formulas are. Area of a square is length times width, or a rectangle. Perimeter of a square or a rectangle is just side plus side plus side plus side, right? That's the perimeter of any shape. Now, if you Google perimeter of a rectangle, you're going to see a formula that looks like this. 2 times L plus 2 times W. However, that's a little bit algebraic for some of our friends in here. Friends, wow, here I am talking in first grade language. You can tell I've been with elementary schoolers all day. Summer school started for us. So if this is my length and this is my width and this is my length and this is my width, my perimeter is going to be 2 L's plus 2 W's. So that's where that comes from. But rather than just committing an extra formula in my head, I'm always thinking that perimeter is just the distance around a shape. That way, when I get a shape that I'm not so sure of, like this maybe, that doesn't have a formula, I know I'm just adding all the sides together. So that said, if my area is length times width, my perimeter is side plus side plus side plus side, and I know that it's a square, what does that do for me? What does a square, how is that important? Because a square has all equal sides. So a square has all equal sides, which really means when I go to do my area formula, area equals length times width, I'm really just doing the same thing times itself, which means my area, which is 6,724, is going to equal side squared, which means I can just square root it. So one side is going to equal. Now, if I don't have a calculator to be able to do the square root, I can definitely sit here and kind of plunk away and figure it out. I'm going to use my calculator because I have one. So the square root of 6,724 is 82. And I know that 82 plus 82 plus 82 plus 82 equals 328. However, that is not the answer, because we did not take into account the fact that her house is 36 feet long and this property is right behind her house. So if her house is sitting right here, here's her house. If that's her house, how does that change our perspective on this problem? It means that this entire length is still 82. However, do I need 82 feet of fencing on that side? I don't. I need 82 minus 36. So I definitely need 82 plus 82 plus 82 because I have these three sides. But then I need 82 minus 36. Does it matter how much is over here and how much is over here? It doesn't. It doesn't matter if there's 10 and, I don't know, 30 or whatever it is. It doesn't matter if the house is centered or not. You're still going to need the same amount of fencing. So I'm going to do 82 minus 36. And that's going to give me how much fencing I need to frame out my yard. And that's going to equal 46. So then when I do 82 plus 82 plus 82 plus 46, I get 292 feet, which is C. Interesting problem, isn't it? Joseph, why do you think the answer choice is not there? 82 plus 82 plus 82 plus 82 minus 36 is 46. Looking at that problem, how do we know the house is, got it, is in the fence line? So honestly, I wrote this problem and I'm not a test writer. So it should have said like the house is 36 feet long and the house is on the fence line or something like that. So you could argue that it could be C or D in this case because the problem was not clearly written, okay? So That's because I'm not a test writer. I'm a assistant principal. So that was a really good question, Ricardo. I'm glad you asked that. So you could technically argue that the answer is D. However, I will argue that rarely will they give you extraneous information. They might here and there just to see if you know what you're doing, but 9 times out of 10, they're not going to give you extraneous information. So the information they're providing you is likely going to be needed. Not all the time, but likely. So that's why I used the 36 in this case. So if you solve a problem and you haven't used all of the numbers, it's a great test taking strategy to go back and see, is that number necessary or is it extraneous? Because like I said, sometimes they will give extraneous information. But if you haven't used a number in a problem, I would highly recommend checking yourself to make sure it wasn't necessary. Thank you, Joseph, for answering that question. Because the house is sitting on that fence line, as I'm assuming, we have to take that out because you're not going to put fence where the house is. All right. Let's move on to problem 2. Those were really good questions. I'm glad that you guys asked. A landowner, another land area and fence problem. So let me make sure that this problem is written clearly. A landowner wants to maximize the area enclosed by a rectangular fence. This one's fine. She has 3,200 feet of fencing available for the fence. What is the maximum area she can enclose? Now, this one is really, really interesting because we're looking not for we're looking for an exact number, but we're not looking for the area of the rectangle, right? We're looking for the maximum area of a rectangle. So that said, we have to really consider what that means. This problem is really going to only show up on any exam that allows for quadratics. So if you have quadratics in your blueprint or your study companion, you could see this problem, which is going to be definitely my middle school and high school people, okay? Why? Well, when I see maximum or minimum, I immediately think of a quadratic and I immediately think of a vertex. Because when I look at a quadratic, a line does not have a minimum or a maximum, right? A quadratic does. So if we're looking for maximum area, I know that my parabola will be facing upside down, right? And if my parabola is facing upside down, then I know when I'm looking for maximum area, if I have 3,200 feet of fencing, I could create an XY table and I could think about what times what equals 3,200. Or no, what plus what plus what plus what equals 3,200. So I could have a rectangle that has a side of 1, a side of 1, and then 2 sides that are like, I don't know, 1,098, right? But that would take a really long time to figure out what that XY table would look like. So the easiest way to do this is to use our understanding of zeros to figure it out. So I know that area is going to equal length times width, right? What is the only other number that they've provided me with? 3,200. So I know that 3,200 has to equal length times width. Agree? I also know that perimeter has to equal 2. No, that's not the area. Whoa. I also know that perimeter equals 2L times 2W. Now, knowing how to algebraically look at a perimeter is important in this situation. We have to know that perimeter is 2L plus 2W. I know that the perimeter is 3,200 and not the area. So I know I could do 3,200 equals 2L plus 2W, right? 2L plus 2W. So if I want to isolate L or W, what could I do? Subtract. So I know I could do 3,200 minus 2W equals 2L. And then I could divide by 2. And I get 1,600 minus W equals L. Now, watch what I'm going to do. I just figured out that L is the same thing as this. So instead of L, I'm going to put 1,600 minus W here. Now I can find my area. So I can do area equals W times 1,600 minus W. And I can distribute, and you're going to see what's happening. Area equals 1,600 W minus W squared. If I have a quadratic equation, what can I do with that? Find my vertex. If I find my vertex, I can find my maximum area. So my whole intent with doing that was to be able to get two things to multiply together to find the area so I can find the maximum area, because my function is area equals. So my maximum is going to be in terms of area. So I can go ahead and find my vertex by doing negative b over 2a and then plugging that in, right? So I'm going to write this in standard form. Area equals negative w squared plus 1,600 w plus 0, which is my c. So I'm going to have negative b over 2a. X equals negative b over 2 times a is negative 1. So 1,600 divided by 2 is 800. What does the 800 represent? The 800 represents the x value of my vertex. Then when I plug the 800 back in, I can find the area. The x value of my vertex is what? Width. Because the w is representing that x axis. So now when I plug 800 in, it's going to give me my maximum area. Let's go ahead and do that. Negative 800 squared plus 1,600 times 800 plus 0. 1,600 times 800 equals 1,280,000. So I'm going to continue this over here. And 800 squared equals 640,000. But that's a negative value. Because this is not parentheses negative w squared, it's negative w squared. By order of operations, we do exponents and then we multiply. And that's technically a negative 1 times w squared. So I'm going to evaluate the exponent first and then multiply by a negative. So this is a negative 640,000. Now I just evaluate that. 1,280,000 600,000 minus 640,000 equals 640,000, which is A, is the maximum area that we can enclose. If I plugged in 800 into the W to find my length, what would my length be? The length would be 800 as well. For those of you taking a high school or a middle school exam where quadratics might be important, maximum area of a rectangle is always going to be a square. It's going to give you the most bang for your buck. So just keep that in mind when you're solving these kinds of problems. Because if you remembered that, you could probably have come to your answer a little bit quicker, right? Because as soon as you found the width, you would have been able to find the answer. That feels like a lot of work when I got the same answer by doing 3,200 divided by 4 equals 800, and then 800 times 800 for the area. Okay, so Jessica, yes, you did 3,200 divided by 4, but by doing that, you assumed that it was a square. And this said technically that it was a rectangle. If it said that it was a square fence, then we would absolutely be able to assume that. But we can't assume that it's a square automatically unless you know that using quadratics, a square is going to give you the maximum area for a rectangular fence. But not everybody knows that. And because they defined it as a rectangle, not a square, we can't assume that all 4 sides are the same. Again, unless you know that a square is going to give you the maximum area automatically. So you happened to get lucky in that situation, but when we're finding maximum or minimum of anything, we want to look at doing quadratics. So I'm glad that you were able to get the right answer. That's the goal, right? Even if we don't do it the way that like I do it or the right way, if you get the right answer, it's all that matters in this kind of situation. So excellent job getting the right answer, though. That makes me super happy. That's our goal. All right, let's move on to problem number 3. The heights of a rectangle and trapezoid are congruent. However, only one of the bases are congruent, where the other base of the trapezoid is 8 more than 3 times the base of the rectangle. What is the area of the trapezoid? Man, we are doing some geometry today, aren't we? So what I'm going to do is I'm going to draw my rectangle and trapezoid. So I have my rectangle and I have my trapezoid, and I'm just going to draw a good old classic trapezoid. There's lots of ways we can draw a trapezoid, but that's the way I'm going to choose to draw it. And it says that the heights, or we could call this length, are congruent. This is base 1, this is base 2, and this is height. So these are congruent. However, only one of the bases are congruent. So this is congruent to this, where the other base of the trapezoid, this, is base is, now taking words and translating them into an algebraic expression is extremely critical for almost everybody in this room. So I'm going to take this entire phrase and translate it into numbers. So base equals 8 more than. We have talked about this in my boot camps. If you are part of my boot camps, you have heard me get on this, I don't know, soapbox. So I'm actually going to do a little soapbox here. Here's what I want you to know. When we are translating algebraic words into an expression, if I have 5 more than 8. What does that look like? Well, a lot of us would think that that is 5 plus 8, which is 13. However, technicality-wise, that is not what it's saying. It's saying that I want to do 8 plus 5, which is 13. Now, you're sitting there saying, Amy, stop. Addition is commutative, so why does it matter? It doesn't. So in this problem, it's not going to matter. However, if it said 8 less than 3 times the base, it would matter because subtraction is not commutative. So let's take a look at 5 less than 8. I want you to tell me, if I told you that, like if I walked up to you on the streets and said, what is 5 less than 8? What would you tell me? If I walked up to you in the streets and said, what is 5 less than 8? What would you tell me? You would tell me 3. You would be like, 5 less than 8 is 3. Like 5 smaller than 8 is 3. Is that because you did 5 minus 8 or you did 8 minus 5? See where I'm going with this? So when we see something more than something or something less than something, what we are actually doing when we represent that is 5 less than 8 means something minus 5, something plus 5, which means we're looking at 8 minus 5. Now, again, you're like, that seems so simple. It seems so simple when we have numbers. But when we have variables involved where you can't prove it, it is not so simple. So let's take a look at this. 8 more than something plus 8, 3 times the base of the rectangle. 3 times, and I'm going to call it B just because it's the base of the rectangle, and we'll call this B. Now, what is the area of the trapezoid? Well, the area of the trapezoid is going to be area equals, and I need to pull out my reference sheet just because I don't have it memorized. Now, if I was going in to take a high school exam, you best believe I'm going to have it memorized if it's not on my reference sheet. Area of a trapezoid. Base 1 plus base 2 divided by 2 times h. So I'm going to take this base plus this base, divide it by 2, and then times h. So base 1 plus base 2, and I'm going to call that, actually, I'm going to call that W. 3W plus 8 divided by 2 times h. Now, is it necessary to call it W? As I'm reading back over this problem, which is important, it says one of the bases are congruent. So this equals this. And then it says the other base is in terms of that base. Because they are in terms of each other, these are actually going to be the same variable, which is important to note. Because they said the bases are congruent and then the other base is 8 more than 3 times the base of the rectangle, which is the same variable as the top of the trapezoid. So now I have 4b plus 8 divided by 2 times h. I could also technically rewrite this as 1/2 times 4b plus 8 times h. Agree? Now, as I'm doing this, I'm constantly looking at my formulas to the left, my A, B, C, and D, to see, because you never know at what point they're going to stop simplifying, because sometimes they're going to stop simplifying a little early to try to trick you. As I'm looking at my answer choices, I know it's not A. This is not going to turn into a base times height. I also know it's not B, because it's not just 1/2 base times height. That's a triangle. So I'm debating between C and D. Now, when I simplify this, I'm going to go back to this version. 4b divided by 2 is 2b, and 8 divided by 2 is 4. So if I simplify that orange piece and then leave my h, my answer ends up being D. Why is it not C? It's not C because the formula for trapezoid is not 1/2 base times height. And this is 1/2 base, which is just one base, times height. The formula for trapezoid is base plus base divided by 2 times height. So we have to be really careful to watch that. This was a really, really complicated problem, only because it required a little bit of extra thinking. All right, let me go back and look at these comments. 1/2 the sum of the bases divided by h multiplied by h. How do you tell the difference between a equals 1/2 base times height and a equals base times height? Thank you, Joseph, for answering that question. It's just different formulas. You just have to know the formulas. I always remember that a triangle is 1/2 base times height, because when I look at a rectangle, I'm going to draw it in pink so that I can erase it. When I look at a rectangle, my rectangle is base times height. But then if I create a triangle from that, it's literally half. So the area of that triangle is going to be half of my rectangle. So that's why it's 1/2 base times height. Excellent questions, y'all. You are coming in with the best questions this week. I love it. All right. Skip my notes page. Let's go on to problem number 4. Now, you'll see a star next to it because someone specifically requested volume. Someone specifically requested volume. So here is a volume problem. Stephen purchased a box shaped like a triangular prism that has a volume of 168 inches cubed. If the triangles have an area of 24 inches squared, what could the dimensions of the box be? I am always going to start with a picture. Could this be on an elementary exam? Technically, everything inside of this almost could. It almost could be on an elementary exam. There's a little bit of Pythagorean theorem. So because of that, we could go a different route with it. But it almost could be on an elementary exam. So I'm going to draw my triangular prism. Does it have to look like this? No, it could look a little different, but this is just how I draw triangular prisms. Okay, it has a volume of 168 inches cubed, and we're looking for the dimensions. So if I know I'm looking for dimensions, that means I need to know what the volume formula is. Volume of a prism equals area of the base times the height of the prism. Area of base times height of prism. So the height of the prism is always going to be the distance between your two bases. Because this is a triangular prism, this is going to have triangle bases. So I know that this is a base, and I know this is a base, which means this is my height of my prism. So I know that the area of my triangles equals 24 inches squared, which means that my box height, my prism height needs to be something that's going to give me 168 inches cubed. And you're like, whoa, how did you get that? Well, if volume equals area of the base times the height of the box, and they gave me the area of the base, all I need is the height of the box to then find my volume. So if I divide 168 by 24, I can get my height. Let's go ahead and do that. Now, I'm going to use a calculator. If you're taking an elementary exam, you might not use a calculator. So I'm going to do 168 divided by 24, which is 7. So I know my height is 7, which means A and C are out because they are giving box heights of 8. Now, is my base length going to be 12 with a slant height of 10? Or is my base length going to be 6 with a slant height of 4? My base length is going to be this distance right here. So it could be 12 with a slant height of 10, or it could be 6 with a slant height of 4. Think about how we find area of a triangle. Area of a triangle is 1/2 base times height. So if I multiply 6 times 4, I get 24. But that's not how I find the area of a triangle. I have to find the height of my triangle, which is not the slant height. I want you to think about when you take your kid to the doctor or when you go to the doctor and they say, let's see how tall you are. Do you stick your feet out way far away from the wall and then you stand like this? Or do you stand up nice and tall with your feet up against the wall? You stand up nice and tall with your feet up against the wall, which is why the height of the triangle is the straight up and down height. Well, in this situation, to be quite frank, I wouldn't need to find my Pythagorean theorem. Let me explain why. In order to find this height, I would need to take half of the base length and then do a squared plus b squared equals c squared. So let's take this for example. So if I have a right triangle, but my whole triangle has a base length of 6, that means that this would be 3 and this is 4. What do we know about right triangles? We know that the hypotenuse is always the longest side. So by using a little bit of common sense, if the hypotenuse is always the longest side, that means this has to be like 2 or 3.5 or something like that. I don't need to know that, right? Let's say it's 3.5. When I do my area formula, my base is still 6. Area equals 1/2 times 6 times 3.5. You could even say it's 3.9. Is that going to give me an area of 24? It is not, because half of 6 is 3 and 3 times 3 is 9. It's not even close. Therefore, my answer is D. Now, let me show you why. when I draw my triangle, my base length is 12, which means when I drop my height to create a smaller right triangle, my slant height is 10, which means this is 6 right here. So when I try to find my height, my actual height, I'm going to do a squared plus b squared equals c squared. 36 plus b squared equals 100. B squared equals 64. So the square root of 64 is 8, making this the actual height. And when I check it, the area of my triangle equals 1/2 base times height, which 12 times 8 divided by 2. And I created this problem incorrectly. So let's say the triangle has an area of 48. That's going to totally mess up the problem. Anyways, I thought I was so creative with coming up with this problem, and then I didn't take into consideration that the base is still 12, not 6. So in my head, when I was creating this problem, the base was 6, not 12. But I have to remember that the entire base is 12. I'm actually going to rewrite this problem to be correct, just because I really, really, really like this problem, and I want to make sure that it's correct for the next time I use it. So does all of that make sense with the problem? So we're going to erase this and say none of them are correct. But does the process make sense for solving that, which is really the more important part? All right, makes sense. Awesome. Let's move on to the next problem. Sean is building a structure out of PVC piping. He has 3/4 yard of PVC piping. How many equal pieces can he cut the pipe into if each piece needs to be 1/5 yards? This right here is dividing fractions. And I had someone specifically ask me for a dividing fractions problem. Now, you're like, how is this dividing fractions? I want you to imagine now, if this problem, you read this problem and you were like, whoa, I have no idea what to do. I sometimes like to change the numbers really quickly in the problem. I still do this strategy to this day to make it make more sense. So what if he has 12 yards of PVC piping? How many equal pieces can he cut if each piece is 3 yards? What would you do? You would do 12 divided by 3 because each piece is 3 yards, and you would get 4 equal pieces, right? So now knowing that took me how long? 10 seconds. I would really do this on this problem if I didn't know how to do it. Now I'm going to take 3/4 and divide it by 1/5. Now, how do I divide fractions? Keep the first one, change the symbol, flip the second fraction. Keep, change, flip. You got to know that. So this becomes 3/4 times 5/1. How do I multiply fractions? Multiply it straight across. 3 times 5 is 15. 4 times 1 is 4. Now, I'm going to do 15 divided by 4 without my calculator because this is an elementary problem. 15 divided by 4 is 3. Add a 0. 4 goes into 37 times. 28. 4 goes into 25 times. So my answer is 3.75. What did the problem ask us, though? How many equal pieces. Equal being the key word. Here's the thing. What does our answer mean? Our answer means that I can cut 3 pieces into this size, and then I'm going to have some left over that is not going to be enough to create another piece that's this size. So how many pieces does Sean have? Sean has 4 pieces. How many equal pieces does Sean have? Sean only has 3 equal pieces because he didn't have enough to create that 4th equal piece. Any questions about that? The next problem is a piecewise function. This one's super cool. I am obsessed with piecewise functions. I don't know why. I have always loved piecewise functions. This is for my 6 through 12, 7 through 12 people. This is especially for you. I just did an elementary problem. Now we're jumping to high school. All right. What is a piecewise function? People get so up in their head about piecewise functions. A piecewise function is a function that's been puzzle pieced together. That's all it is. It's just a little bit of this function, a little bit of this function, a little bit of this function, and they all get pieced together. So let's take a look at what the problem asks, and then I'll explain it as a piecewise function. A piecewise function is defined below. Find f of 3 for the piecewise function. F of x equals 2x minus 5 if x is less than 3. F of x equals negative 6x plus 3 if x is greater than or equal to 3 but less than 5. And 5x squared plus 2, f of x equals if x is greater than or equal to 5. So let's go ahead. Let me show you what this is going to look like. It's going to be a little hard because I can't erase just pieces of this, but I'm going to graph this one. 2x minus 5. Go down 5. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. And x is less than 3. So that means that this graph looks like this. But we're only using the piece where x is less than 3. So I am going to draw an open circle at 3 and only connect these parts. Now, negative 6x plus 3. I'm going to graph that. 1, 2, 3. Negative 6. 1, 2, 3, 4, 5, 6, 1. 1, 2, 3, 4, 5, 6, 1. This graph is extremely steep to the point where we're not going to be able to see that part of the function. Because what's going to end up happening is that part of the function is going to be from 3 to 5. So we're going to have that really steep graph way down here between here and here. Okay? And then 5x squared plus 2 is going to be anywhere where x is greater than 5. So greater than 5, I don't know where that graph is going to land, but it might look something like this because it's a parabola. Okay? Now, I want you to look at these intervals. They want us to find f of 3. They want us to find the function's value at x is 3. Am I going to plug it in to all of these, or am I going to just plug it into one? I'm only going to plug it into one because each graph has its own section of the graph on the x-axis. So I need to figure out which one of these graphs is going to be where x equals 3. And that's going to be this graph, because it includes the 3. This one does not include the 3. It's everything less than 3. Then it's from 3, including 3, all the way to 5, not including 5. And then the next graph is including 5 and on. So I'm literally just going to plug in 3 into the second equation. And get A as my answer. All right. What questions do you have? Can we just celebrate something for a minute? For those of you who are here every week, can we talk about how this did not disconnect the entire time that we've been working together today? If you are new, the iPad disconnects at least 3 or 4 times every single time we get together. So I didn't do anything different. I don't know what I did differently, but it stayed connected the entire time, and I consider that a huge win. So let's just celebrate that. I'm going to turn it back over to Dr. A. I'm going to hang out while he finishes up, and I'm going to check. I love that Joe said this. Oh, you are always my cheer squad. I love it because you get it. Thank you, TJ. I'm going to turn it back over to Dr. A. I'm going to hang out for a minute. I'm going to check in to the comments. Let me know what you want to see me work through next week. Thanks, Ricardo. Thanks, Josh. You're new, but congrats. Listen, it's a big deal. We've been here for a while, and it is a huge deal that this thing didn't disconnect because it's just a pain. We're in the middle of a problem, so excited, and then poof, it's gone. Let me know in the comments what you guys want to see next week. What are you struggling with as you are prepping for your exam? Let me know in the comments. I will make sure to include it next week. I'm going to turn it back over to Dr. A. It is officially summer. Tomorrow starts hurricane season. If you live in Florida, you know that that's a big deal. So maybe that'll be my question next week. How many hurricanes have you lived in? That'll be our question next week. You are so welcome. I'm so glad you guys are enjoying this, and I will see you guys next week. See ya.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.